I would like to take your attention and make a few notes. Number one, notice the syntax for making copy, right? We just basically say, let's have st2 equal st, which already is an existing object. So one more time, just want to revisit this part, right? I'd like to say that basically what happens is that we have this main, right? Main, it has its local scope. We construct an object there named st, right? And initially it has a pointer to some other scope in dynamic memory which allocates the default size of this array of integers, and it keeps track of that array of integers by storing a pointer inside the object, right? So this is the main function that has some code, but anytime we use local variables, they're placed in this stack frame that belongs to main. Then we call use stack, right? And what we do, of course, instead of making a copy of this box, instead, what we pass this reference, how we call it, we call this another, right? We pass this reference another, but this is not a copy, another is not a copy of this box. It simply is a reference. It's a second name for it. So anytime we say another, it's the same as the original object. But this time, of course, it happens in a scope of, in local scope of function use stack in a different function, which is quite fine. This time, this is what happens. But then we, inside use stack, make something else. What we say in stack, right? And we say st2. Let me just be a little bit more conservative in the way I'm writing this, right? So we say in stack st2 equals st. Okay, st. And oh, I apologize. This was not another. This was called st. I don't think I named it differently. In the scope, st was the name of the function parameter, right? If you look, this is the name of the reference, st. It's not another. Or a little bit too soon to call it another. All right, so st is here. Okay, and it's a reference to the same box, and therefore it manages the same memory. So, but we made sure that whenever there's a copy, right, an attempt to copy something, we provided a special type of constructor, which was a copy constructor for in-stack. In-stack. And this in-stack copy constructor, what it did was it took in-stack a reference to another, right? We said it takes basically it takes its own parameter, so this stack becomes another inside this copy constructor when it gets invoked, and the copy constructor itself is invoked for this object that we're trying to construct, copy construct, right? To make a copy of it. So we can say that, let me just push this a little bit up there so that I have more space, right? So then constructor executes, right? Constructor executes, and what happens is that it has this another as a parameter, right? But this another is just a reference. You can see that this is a reference to yet again the same object, right? So far. So now we're on the stack, we have three function calls: main, use stack, and then copy constructor executes. All of them have their own local scope and from the scope of the copy constructor, we have access to the original object, right? And so far, we're somewhere here, and then what we do inside this constructor, we simply say top of stack and capacity, right? Well, first of all, I must say that when you make a copy, before constructor is invoked, the memory for the new object, the memory for this object st2 is already allocated inside this function, right? Because we say that we want to construct, I'm sorry, once again, it's over here, right? Inside in stack, right? When we say use stack, we construct this object and it's inside use stack, right? So the space for the stack box is allocated, and constructor basically, when constructor executes, the constructor has access to this brand new box, and what it does, it then populates top of stack and capacity, right? So top of stack of the original object and capacity are, the values are copied over here, right? So we copy the values. Now this is in memory. Then what we do, we say allocate memory for this brand new object. So this brand new object gets new block of memory right here, right? It's somewhere on the heap or on the free store, right? And then before the copy constructor is over, we use this loop to say another, like another over here, right? Another is pointing to the original object, which was passed all the way from main to this constructor. So it basically says another, we want a copy of all of your elements. Every single integer gets moved over to the brand new thing. And then, of course, what happens is that after that happens, this constructor is done, it returns, we have this. Then, unfortunately, we really don't do much use of this. This whole thing immediately returns, and the destructor is invoked and it goes away. So all of this goes away, and eventually we're back in main function. But the net result so far is that by providing this copy constructor to the stack class, this original object is now safe, and a copy of it is also safe, and we can rely on the existence of the copy constructor. Now, there's also another type of thing that we can do with objects that comes from C programming language, because we essentially inherit that from the ability of C programming language to make copies, right? So we could have constructed, so this is deep copy, but if I say int stack and create yet another object, st3, okay? If I make st3, now this time, of course, it invokes the default constructor. Right, default constructor is invoked, and I create yet another, like third copy of this object. And then what C provides is that you can say st3 equals st, right? So C also allows default assignment. Again, just like with default copy constructor, what default assignment does, it simply copies all bits from the original stack over to st3, which is yet another, like, third copy of this box, right? So let's review this very quickly. So if we say use stack, now instead of creating st2 only in its local scope, right, it actually creates st2, which is now a good copy of the stack that was constructed by main, right? We have that, but we also construct st3 in its scope, right? which is just a box which has a pointer to some default memory allocation, but it's completely independent from ST2 and the original stack ST. But look what happens on this line. We say, hey, let's just use straightforward bitwise C assignment, which basically transfers all bits. And look what happens as a result. When we say ST3 equals ST, right? What happens is that we take all bits, all zeros and ones inside here, and populate them inside this box. And therefore, two bad things happen. Number one, we lose this connection, right? Because instead, what happens is that we just forcefully repointing this to the same memory location. Okay, and again, this is shallow assignment, plus with the side effect that we lose connection with some memory allocated by the default constructor for ST3. So the number of bad things is piling up, okay? The number of bad things is piling up because we still have to take care of the second thing, which is the default behavior of the assignment. To do that, and I am not going to spend too much time, but I'd like to finish this in one session, if you will, right? So in order to implement assignment, what I'm going to do, essentially to control the semantics of the assignment, if I was able to control the semantics of making copies, now I will take care of the assignment. And on top of my operations, I will provide something like int stack reference return from operator equals, and this operator equals takes the same similar parameter, just a reference to another stack, and this is going to be the something we will call overloaded assignment operator. Okay, right here. So it has the strange function name operator equals. This is actually the name of the function which will be invoked when this assignment operator is used between the two stacks. And what I need to do, of course, I need to provide its implementation, Control C, right? Take the prototype of this function and essentially just add it somewhere next to this copy constructor, right? And again, this instack is going to be the scope of this operator. This, I apologize for all of the craziness of the syntax, but just to let you know that this issue still exists, so I would like to make sure that we take care of it. Let's just save the segment and switch over to the next segment before we finish this implementation.